Now, those pre-stress losses or pre-stress loss, the existence of pre-stress loss that we have mentioned a while ago, actually have what we call categories. So there are actually categories of pre-stress loss. So actually there are two categories. So the first category of pre-stress loss is the immediate elastic loss during the fabrication or construction process, including elastic shortening of the concrete, anchorage losses, and frictional losses. So these are actually pre-stress losses that usually occur immediately. So this is actually not time dependent. So you can expect that uh, along with the early stages of pre-stressing, you can expect that this particular losses immediately occur on the pre-stressing reinforcement, thereby uh, producing pre-stress losses at the early stages of pre-stressing. So that is the first category of pre-stress loss, the immediate elastic loss. The second one is exactly the opposite of the first one, which is or which are the time-dependent losses such as creep, shrinkage, and those due to temperature effects and still relaxation, all of which are determinable at the service load limit state of stress in the pre-stress concrete element. So you can see here the second category of pre-stress loss uh, is actually those losses that usually occur after some time after the pre-stress force is already transferred from the pre-stressing reinforcement to the concrete element. And this particular time-dependent losses actually include the creep, the shrinkage, the temperature effects, as well as the still, rel still relaxation. While for the immediate elastic loss, uh, this usually includes elastic shortening of the concrete, anchorage losses, and frictional losses. So you again, like what I've said before, these particular losses, the immediate elastic loss, usually occur at the early stages of pre-stressing. That's the first category. While the second category, the time-dependent losses such as the creep, shrinkage, temperature effects, and still relaxation, usually occurs after some time, after the pre-stressing uh, was done. Although uh, you have to realize that the exact determination of the magnitude of these losses that I have mentioned, particularly the time-dependent ones, is not feasible since they depend on a multiplicity of interrelated factors. So we cannot actually determine an exact magnitude of these pre-stress losses that I have mentioned here that are divided into two categories. We cannot determine all of those exact magnitudes, but we can just estimate their actual magnitudes using empirical methods of estimating losses. Although we actually have different uh, different methods, different empirical methods on estimating these pre-stress losses, depending on which particular code of practice or recommendations are you using. So you can use as reference the Prestress Concrete Institute, the ACI-ASC Joint Committee approach, and the ASHTO lump sum approach in computing the or estimating the pre-stress losses that I have mentioned here. So Actually, these references that are mentioned here uh, specifies the different ways or different methods of estimating the particular magnitude of each of the Prestress laws that I have mentioned here. Some of these references actually uh, has uh, almost similar approach on uh, finding the exact, or I mean the estimated magnitude of the pre-stress loss, depending on which particular pre-stress loss we are talking about. Usually, some of these references have the similar approach on finding a particular magnitude of uh, pre-stress loss. Although some of them also uh, have different ways or methods on computing a particular uh, cause of pre-stress loss. So uh, again, these are the particular pre-stress losses that we will talk about on this discussion. They are divided into two categories: the immediate elastic loss and the time-dependent losses. Now, those pre-stress losses are actually mentioned in the code. Specifically, if you would refer on ACI 318M-14, or if you would refer on our local code, the NSCPC 101-15, section 420.3.2.6.1, and for the ACI, section 20.3.2.6.1, you can see that uh, the computation of pre-stress losses are actually included or required by the code, either the international code or the local code that we are using. So according to the code, the pre-stress losses should be considered in the calculation of the effective tensile stress in the pre-stressing reinforcement F sub SE, and shall include uh, the pre-stress reinforcement sitting at transfer, the elastic shortening of concrete, the creep of concrete, the shrinkage of concrete, the relaxation of pre-stress reinforcement, and the friction loss due to intended or unintended curvature in post-tensioning tendons. So you can see here that the calculation of pre-stress losses are actually mandated by the code, either the international or the local. Specifically, the code specifies that the pre-stress losses due to this that are mentioned here on the code provision must be taken into consideration before or for the calculation of what we call the effective tensile stress in the pre-stress reinforcement, or simply the effective pre-stress, which is the pre-stress magnitude that is being experienced by the pre-stressing reinforcement after all the losses uh, have occurred. So that is the stress, or that is actually related to, of course, to the effective pre-stress force, which is the reduced magnitude of the initial pre-stressing force. So again, like I always mention, the initial pre-stress force actually experiences a reduction in magnitude due to the existence of pre-stress losses. That is the main topic of our discussion for this meeting. So the reduced magnitude of that initial pre-stressing force is actually what we call the effective pre-stressing force. And the stress being experienced by the pre-stressing reinforcement due to that effective pre-stressing force is actually what we call the effective pre-stress, or the effective tensile stress in the pre-stress pre-stress reinforcement, or the EPSA SE. So if you will try to scrutinize the code, either the international or our local code, you can see that there is no particular way or method that was presented or included on any of the code provisions of our international or local code. So actually there if you will try to check the particular provisions here, the succeeding provisions, you can actually see that there is actually no specified way of computing the pre-stress losses due to this uh, uh, factors included here on the provision. There is no actually mentioned specific way to compute the pre-stress losses due to this uh, pre-stress loss causes. But if you will refer to ACI 318M-14, if you will try to refer to the commentary on this particular code provision, the R20.3.2.6.1, you can see there that the code actually uh, mentions some references that the designer may refer to uh, for him to be able to compute the estimated magnitude or magnitudes of this particular causes of pre-stress loss, or the particular estimated magnitudes of the pre-stress losses due to these factors mentioned here. So the code just specifies or recommends some references that the designer may refer to if you want to compute for the estimated magnitudes of the pre-stress losses due to these factors mentioned here. So you can see here that the code, specifically on the commentary part, recommends to refer to, say, the Joint ACI-ASC Committee 423, which is this, which is the guide to estimating pre-stress loss, a method or a guide uh, formulated by ACI-ASC Committee 423. So this is actually a collaboration work for the ACI and the ASE, a collaborative work for the ACI and ASE. And we all know that these two or these two are actually two different organizations, a famous organizations with respect to civil engineering practice. So again, ACI stands for American Concrete Institute, and ASE stands for American Society for Civil Engineers, or I mean American Society of Civil Engineers. So you can actually see that particular guide to estimating pre-stress loss on ACI 423.10R-16. Actually, I think this is the latest provision or latest code version of this particular uh, guide made by the Joint ACI ASCE Committee 423. So you can see here, uh, it was specified here, it was enumerated here, the particular methods, empirical methods to be exact, on how to estimate the actual magnitudes of these different pre-stress losses. So another reference that the code recommends is the ACI 435R, which is this, the control of deflection in concrete structures. So this is reported by ACI Committee 435. So if you will refer here, actually some of the provisions specified on these references are, again, like what I've said before, almost the same. So I mean they some of these pre-stress losses, some of the computations of the pre-stress losses specified here are almost the same if you will refer to these different references mentioned here. Although not all, especially the guide to estimating prestress loss. If you will try to check this particular guide, you can see there is actually different way of computing the magnitudes of the prestress losses mentioned here. Actually, it's more of a very empirical method. So if you will try to check it, it's really uh, it really looks like an empirical method because there are a lot of empirical formulas mentioned there. So again, in addition to that, you can also refer to ACI 435R, which has a title of Control of Deflection in Concrete Structures. So another reference that is mentioned here is the PCI Committee on Prestress Losses, which has this front page, and has a title of Prestress Losses in Partially Prestressed High Strength Concrete Beams. So again, if you will try to refer that, or if you will try to refer in this particular document, you can see several ways, or I mean, you can see methods or ways on computing these pre-stress losses mentioned on the code. So last reference that the code recommends is Zia et al. So actually, it's like a journal here or a report. I don't know which is reported by Paul Zia and other contributors here. That's why it's called Zia et al. So the title of the journal, I don't know exactly if it's a journal or a report or whatever. So the title of that document is Estimating Pre-Stress Losses. Actually, the code, ACI in particular, actually uh, prefer this particular document uh, to be used in estimating the magnitudes of the pre-stress losses mentioned here, as you can see here on the commentary. So it's mentioned here that reasonably accurate estimates of pre-stress losses can be calculated in accordance with the recommendations in Zia et al., which is this particular document. So if you want to uh, uh, compute for the estimated magnitudes of the pre-stress losses, you can expect that you can have different magnitudes of pre-stress losses depending on which particular reference you are using. Because again, like what I mentioned, these documents you see here actually have different ways or methods on computing the estimated magnitude of the pre-stress losses due to these factors mentioned on the code. So again, that is those mentioned on those documents, again, are different ways to estimate the particular magnitude of the pre-stress losses. Actually, we have additional way to compute the pre-stress losses that are being experienced by the pre-stressing reinforcement. Actually, if you will refer again, if you will refer in this particular documents, you can see that uh, the the pre-stress losses due to these factors mentioned here are actually presented on these documents individually. So you can see there that the the empirical methods or empirical formulas or simply the formulas to compute the pre-stress losses are presented on this document individually, meaning we have a separate way on how to compute the pre-stress losses due to the pre-stress reinforcement seating and transfer. We have different way on computing, or we have another way or separate method to compute the pre-stress loss due to elastic shortening of concrete, due to creep of concrete, due to shrinkage of concrete, etc., etc. Uh, you can see those on these documents presented here. The pre-stress losses, the methods or the method of computing the pre-stress losses are presented on these documents individually. So you can find the individual magnitudes of the pre-stressing losses or pre-stress losses with respect to these different factors. But we actually have another way, another method of estimating pre-stress losses, which is what we call the lump sum approach, which actually presents the pre-stress losses as a whole instead of individually, just like what I have mentioned on the way the documents previously stated presents the methods of estimating pre-stress losses. So in lump sum approach, again, the pre-stress losses are presented as a whole with, meaning that instead of presenting how to compute the individual pre-stress losses due to the different factors that are mentioned on the code, instead of individually mentioning them, the different ways of computing the individual causes of pre-stress loss. Instead of that, in lump sum approach, it instead presents the pre-stress loss being experienced by the pre-stressing reinforcement as a whole, or in terms of the total of the individual pre-stress losses that that might be experienced by the pre-stressing reinforcement. So instead of itemizing the individual causes of pre-stress losses in lump sum approach, it instead presents the total of those pre-stress losses, individual pre-stress losses. So if you will try to refer on Ashton lump sum losses, you can see there that uh, if according to the Ashton lump sum losses, it's mentioned there that if the type of pre-stressing steel is a pretensioning strut, which is again usually used on pretension operations, according to Ashton lump sum losses, it is estimated that the total loss that this particular pre-stressing reinforcement will experience all throughout the pre-stressing operation will sum up to a total magnitude of 45,000 psi or 310 megapascal. And if you will use a post-tensioning wire or strand, according to lump sum losses, the estimated total loss that will be experienced by this particular pre-stressing reinforcement all throughout the pre-stressing operation uh, is estimated to be equal to 32,000 psi or 221 megapascal if you will try to use a concrete with a compressive strength of 4,000 psi or 27.6 megapascal compressive strength, or it will also sum up to a magnitude of 33,000 psi or 228 megapascal if you will use a compressive strength of 5,000 psi or 34.5 megapascal. So, and lastly, according to Ashton lump sum losses, if you will use bars as pre-stressing reinforcement, it is estimated to experience a total loss of 22,000 psi or 152 megapascal if you will use FC prime is equal to 4,000 megapascal, and 23,000 psi or 159 megapascal if you will use FC prime is equal to 5,000 psi. So in lump sum approach, the losses are presented not individually but as a whole. The losses are presented, or the magnitudes of the pre-stress losses are not presented individually, but as a whole on lump sum approach. So you can refer to Ashton lump sum losses if you want uh, to uh, to be familiar with the estimated total loss that a particular pre-stressing reinforcement may experience along the pre-stressing operations. Although you have to take note that the pre-stress losses mentioned here do not include the losses due to friction. So if you want to include or if you want to consider the losses due to friction, you have to compute it separately according to AASHTO specifications. So that is for AASHTO lump sum losses. Actually, you can also refer to the lump sum losses specified by the Post-Tensioning Institute, although these losses are just applicable to post-tensioning, obviously, because it came from the Post-Tensioning Institute. So again, according to this table, similar approach or similar interpretation as this table from AASHTO. So according to this table, if you will use a pre-stressing reinforcement of stress relief 270 kips, or I mean K 270 kip strand or K strand, and stress relief 240 K wire, it is estimated that the total pre-stress loss that will be experienced by that particular pre-stressing reinforcement, if you will try to use slab, the estimated total loss is or has a magnitude of 30,000 psi or 207 megapascal for slabs and 35,000 or 241 megapascal for beams and joists. And for bars, 20,000 or 138 megapascal for slabs and 25,000 or 172 megapascal for beams and joists. And lastly, if you will use a pre-stressing reinforcement of low relaxation 270K strand, it is estimated that the total loss that will be experienced by this particular pre-stressing reinforcement for the case of slabs is equal to 15,000 psi, or in the case of beams and joists, equal to 20,000 psi. So you can refer that for uh, estimated total losses for post-tensioning. So you can refer that from the Post-Tensioning Institute. But again, you have to take note that the Prestress losses presented here, according to this note here, do not include losses due to friction. So again, if you want to consider losses due to friction, you have to compute it separately. And again, these total losses you are seeing here, although they do not include the losses due to friction, but they include pre-stress losses due to elastic shortening, relaxation in the pre-stressing steel, as well as the creep and shrinkage. So those are the pre-stress losses that are considered on estimating these total losses in lump sum approach. And you just have to keep in mind that this lump sum approach, these total losses you are seeing here from AASHTO and Post-Tensioning Institute, are applicable only to routine or standard conditions of loading. So you have to comply with that particular requirement first before you will be able to use lump sum approach. So again, lump sum approach is usually used on routine standard conditions of loading.